Hello students, welcome to the Numpy tutorial. So in this chapter, you're going to learn all about Numpy, how to use the package, everything in 5 different sections. So I have just split it into 5 different sections since it is like I'm going to cover wide content. So you will see 5 different video tutorials for all these 5 sections. So let's start with section 1. It is Numpy Introduction, where I'm going to speak about what is the special things about Numpy, why do we need to learn this, how are we going to apply it in a real world scenario, and how to create data in Numpy, and then how to access the element in Numpy. Okay, so these are the stuff that basic stuff that I'm going to cover in this video tutorial, that is section 1 of Numpy. Okay, so let's speak about what is Numpy. Okay, might be already familiar like of this library, this very useful library. So as we know, Python is so popular because of its libraries, packages. Okay, it has packages for different fields, whether it is data analysis, visualization, or any kind of area, machine learning. It has a lot of packages available. Particularly when it comes to data handling, it has wide variety of libraries available. So NumPy is a very important library. Like you cannot avoid NumPy with like when it comes to data analytics for basic data pre-processing. It is the first thing that you would do. You will import NumPy packages and use its method to do basic pre-processing on the data. Okay, so it is shorthand for the term numerical Python, NumPy. So it's the most important fundamental package for data analysis. So it has the wide collection of pre-written methods for handling, capable of handling the data, manipulating the data, and performing any kind of operations, okay, on the data, any kind of, can be arithmetic, statistical, linear algebra. So it has the methods for different kind of operation that we need to perform on the data, okay, depending on the application. So mostly it provides all the functionalities to deal with the numerical data, okay. So even if it is an image, it can be considered as a matrix array. Okay, so mostly the main use will be how to handle array kind of data, matrix kind of data. Matrix is nothing but the two-dimensional array. Okay, array is like you can work with multi-dimensional content, but matrix is two-dimensional array. So NumPy is useful to handle these kind of numerical data. Okay, row and column or two-dimensional or three-dimensional data. So first we'll speak about the array because that is the main focus that we're going to work more functionalities on array. So the main feature of NumPy is it's easy to create and manipulate the array. Okay, so unlike the other tightly typed languages like C++ and Java, the one thing about Python or NumPy packages, it is heterogeneous. You can just use any kind of data structures. Okay, you can just work on that as a single array, heterogeneous. Okay, so that we are going to learn. So why we have other libraries or that packages or that too. Pandas is the one efficient and another package that we are going to learn in the next chapter. But why NumPy? Because as I explained in this package introduction, it is computationally stable and efficient because of many reasons. Comparing to the raw Python or any other library, NumPy has a lot of advantages. Okay, we'll see one by one. Before that, to import NumPy, this is the code. Normally, import is the keyword that you'll use to import any packages, right? So NumPy is the name, and then we are importing it as NumPy so that we don't need to use that package name everywhere. You can simply use with the nickname NP. Okay, so this is the code to import the NumPy. Now let's see few of the highlights about NumPy. So first thing is it stores the data as a continuous block of memory. Okay, so for in other built-in Python methods, other data types like it is list is continuous, but the thing is like it doesn't have that many methods. Okay, so one good thing about the NumPy is since it stores the data as a continuous block of memory, it uses less memory and also it provides the fast array oriented programming. Okay, less memory, fast. So these are the two main advantages. And then since it can handle array, this built-in developed to handle arrays, you can avoid writing loops. But particularly when you need to write, manipulate the arrays in raw Python, you need to use for loop to iterate through the values, to iterate through indices. But due to its built-in structure, now using NumPy, you can just manipulate the array without writing the loop, without the need of writing loops. Okay, so that is another advantage, and it has a lot of methods available in the package for linear algebra operation, random number generation, and Fourier transform. So like that, there are many highly complex methodologies, mathematics, complex operations can be done using the methodologies, using the methods. Okay, because already someone has written all those, they have solved the problem, they have written the code, and we can just borrow this code by just importing this package. And the another advantage is it has proper functionalities that will help to read and write the data from the disk, to import the file, to import the external file, or to export those kind of functionalities, file handling and writing to the external devices, reading from the external devices. These are the important basic operations when it comes to data handling that can be done by using NumPy. Okay, the another thing, it is a good application program interface package because when you need to connect with the low-level programming languages like C, C++, many current, like the old version of the applications, already they will have the base code. This is already written in the old, like not old, but the low-level programming languages. So NumPy can get along with that because of its the data storage methods. Because of it, it can work with the low-level languages, so it can just act like an interface between a bridge, okay, bridge between the old base code and the extras, add-ons, okay, that we are working on for the applications. That can be done easily by using NumPy. Okay, so what are you going to learn? Okay, so what we will learn from this at the end of this 5 sections of video tutorials, you will learn different kind of operations, array related operations to perform data cleaning, okay, and then filtering, transformation from one to another. The transformation could be of any kind of transformation, but that should fit with the like for particular computation. Sometimes the data needs to be pre-processed. It cannot be or we cannot apply some kind of operations or functionalities in a particular form. We have to transform it to different form to apply the packages, to apply the what to say, computations, okay, computation or calculation. So that can be done easily. Common array related algorithms like sorting, unique, okay, sorting the given data, unique operations, set operations, those kind of operations can be done very easily, if effortlessly, with the built-in methods available in NumPy. And then data aggregation, summarizing, those kind of performance can be done. We're not going to do the data aggregation in this semester. We'll sorry, in this section. You will learn it later on, but data aggregation functionality is also there in NumPy. And then data alignment, relational data manipulations, that means database merging, joining, those kind of database related operations can be done by using NumPy. Okay. And then group by data manipulation, the aggregation, transformation on different tables, different relational databases, that also can be done. So you're going to learn at least half of the things, how to do the cleaning, transformation, those things. The functionality of data aggregation, those kind of stuff, we will learn it in different chapter. Okay, so after learning this, where we are going to apply, where, in which instances and all, you have to think about using NumPy. Whenever you need to compute a lot of numerical data for analysis, a huge data with the data transformation for pre-processing those stuff, you can rely on NumPy. And whenever you need to deal with abstract ideas like vectors, matrices, arrays, so for that, the different types of numerical data, then you can go with the NumPy, since it has a lot of methods, particularly for each of these different data types. And when we need to perform statistical and linear algebra related calculations, we can use a NumPy. When we need to import the external data or pre-process the external data, we can go for NumPy. When we need to generate the random numbers, the random number generation of NumPy is far more advanced than the raw Python's random number generation. Okay. And then to create arrays of different size, different numerical values, we can, because there are tons of different methods out there, particularly for array creation. We will see that in this chapter, particularly in this section, we will see what are the different methods. Sorry, in the next section of this chapter, we will discuss about what are the different methods are there to create the array for different operation. And then to deal with the statistical distribution, okay, and any kind of statistical, already we have mentioned that, maybe I will take away these points. To deal with it. Okay, so statistical, any kind of statistical related and linear algebra related operation can be done. Okay, advanced, when we need to deal with the advanced data type other than the list, because list has its own restriction, because it's simply the data type. When we need to handle the advanced operations more than the list, then we can go with the array and handling array with the NumPy. Okay, so those things are popular. So because of this reasons, it is important to get the help from NumPy rather than relying on the raw Python. Okay. Okay. So as I told you before, how can you import NumPy? So you can start practicing from this code. So wherever I am explaining, where I'm doing the code, please do it along with me. First, import the NumPy as NP. Now what we are going to do, we are just going to see how we can create arrays. Normally, how we will create array, you can just create the list. List is also heterogeneous data type, right? So you can just create a list variable. Okay, just use your own data variable. Just again, I have just given an example. Okay, now since we have imported the NumPy package as NP, we can just say NP dot. Okay, array is the method that will convert the given list into array. Okay, so maybe I'll do it here. I'll just pass it and do it here so that you can do it along with me. So just import NumPy as NP and then create a variable, list variable. And then we are going to pass NP dot. When you say NumPy dot, if you press tab here, you can just get all the methods available in NumPy package. So here I'm going to use this array method. So what it will do, it will simply convert the list into array. Okay, so I'm just converting the list into array. And if you want to see the type of this, you can simply find type and copy and paste this code. You can see it is going to be ND array. So ND array means n-dimensional array. Okay, so array is normally multi-dimensional array. Matrix means two-dimensional. So ND array is NumPy provides. Like why it is ND? Because you can handle. There is no limitation in terms of dimension. Okay, you can handle n-dimensional, as many dimensions as we need to handle. We can handle it. It provides the industry standard computation with different methodology. Okay. Next, we will do few more things with that. Let's create one more data with both integer and floating point. You can feel free to pass the video, or you can refer the PDF file that I have uploaded. Okay, for getting these things, or feel free to stop the video and type this. Okay, I'm creating another list. Okay, now let's do the same thing again. We are passing this and checking. Okay, you can see that will create it as an array. Let's do one more. This time we are going to do two-dimensional. So with the list of list, already it's a list. Data2 has a list. Inside the list, we have two other lists. Okay, list of list. So let's see how Numpy handles this. How Numpy handles this. Okay, list of list, and then I'm just converting it into array. And then let's see. When I try to see, you can see that is created as an array. But it just take these two lists as a two-dimensional array. Just save it as a two-dimensional array. Okay, now let's see how to convert. So this is the example to convert the list into array. Now let's see how to convert the tuple into the list and then array. So here tuple, as you know, tuple is nothing but the immutable object. Okay, so I am just passing the tuple into array method. So you can see now it will create an array. The tuple values are getting converted as an array values. Okay, so this is how you can use the other data type like list, tuple to create array by using Numpy. Okay, so next we are going to see one more method called mp.array. Using that method only, we have converted all the data type into array. So there is another method called np.asArray. So what it will do, it will convert the given data into array, but the difference is with the parameters. It has very like advanced parameters in as array has. When you make Numpy array using np.array, it will just create a copy of the object, the original object. It would not reflect the changes because it just makes the copy and work on the copied new array. Okay, it will not change the original array because that's the property. But if you use np.asArray, it will reflect the changes. So simply by using array, if you don't want to change the original data, then you can go for array. If you want to work on the original itself, then you can go for array because it doesn't create the copy. It just works on the original data. Okay, so now let's see one example for between the array and array. So this exercise, idea of let's create three arrays. First one is a numerical array using Numpy package ones. Okay, np.ones will create 3x3 array with ones, and np.array that thus will take this one. Okay, and then do it as an array method. That means it will create the copy. And then we are doing the same thing, passing array ARR1, but this time we are creating as array. So that means if you do any change, the change will be done in the original array itself. Okay, let's see how it reacts. We are just going to change this array value, the first index value from 111. Maybe I will just show you what is there in array 1. So if I run it, you can see this is the array that we have created. Now what we are going to do, we are just going to change the first index value 01. That means second index. But then we're going to change it to 2. Okay. So once we change it to 2, let's see what are the stuff that got changed. So let's print all the values, array 1 value, array 2 value, array 3 value to see the change. You can see since the array 1, we are changing it in the array 1 itself, you can see all the second row got changed. Okay, the second one, we have created the array using array. So as I told you, the array will create the copy of the original array. So you can see, since it is typing the original array, there is no change. But if you look at the array 3, then you can see, since we have used the as array method, it changes, it affects the original array. Whatever changes that takes place, that will affect the original array. So you can see that changes it. So that's the difference between array and as array method. So now we are going to see how to access the elements. Okay, how to access the indexing, how to access the elements from the array. For example, let's take this last array and we are going to access 0 index, 0 row. So already you are familiar with this. Okay, we're just pressing your skill on this. Okay, array 0, see 1.0. So the 0 row and 0 column, 1.0. Okay, but what will happen when you do this? You can see when you say array 0, it will pick all the columns from the first row, all the columns from the first row. Okay, so just retrieve everything. Okay, so we there are few attributes that you should be familiar of ND array. So ND array has two attributes called n dimensional and shape. For example, let's take this array 2 where tab. If you press tab, you can see it has a lot of parameters available. Two mostly useful parameters or attributes are n dim. Okay, so if you use this attribute, then you can see what is the dimension of the array. It is 2D array. You can see that it is 2D array. So it just says it is 2D array. And then here tab shape. I'm going to get the shape of the array. You can see the shape of the array is 3 cross 3. Okay, so these are the two attributes. You can refer the Numpy documentation. Okay, so Numpy, I strongly recommend you to refer the Numpy documentation to know more about Numpy. So I have given the link in the PDF. So if you check, you can find the documentation where you can refer all the methods and all the syntax, all those stuff you can find in the documentation. And also you can use the help function here in Jupyter Notebook to know more if you want a quick reference, okay, from the Numpy documentation. The help document, the particular method .help always give you the documentation. We'll fetch the documentation from Numpy and then just show it here in the Jupyter Notebook file that you can do too. Okay, next we are going to see D-type attribute. Okay, so D-type is one popular attribute that will help you to fetch the data type of the data saved in an array. So if you want to see what is the data type of the data saved in an array, then you can just go for D-type. And we will try it. This. We're going to see the D type. Okay, R2D type. Okay, you can simply type tab and then you can simply get the value and run the cell. You can see all the elements. Data is in of floating point. Okay, and then how to create use this D type as a parameter. Okay, not only as the method, you can even use it as a parameter here. So pass this array. I'm creating new array with the list 1, 2, 3 values. And now I'm just want to check it like I want to convert the data as a complex. In the D type, you can either D type will help you to fetch, but if you want to set a data type, then you can use it as an attribute. Okay, so you can see we have created a data with this complex value. You can always change the values. You can use this D type attribute to change any values to any value. D type float. But remember, since we used NP array, the original array will not get changed. But here you're just learning the D type method and attribute. Okay. So this D type as an attribute, when you use it, you can just change the value of the data type by specifying it as a value of this D type parameter. Okay. Next, we are going to see as type. Okay. What is as type? Other than D type, we can also use as type to explicitly convert data from one type to another type. D type will just get the value, and or you can use the parameter to just assign the data type. But you can change the data type by using the as type method. Okay, how to do that? As type. Let's create a new array and let's see what is the type of the. Okay, what is the type? Let's print the type. Okay, let's see. It is in here. Now I'm going to change that to floating point by using as type. Okay, so let me see. Float array, and here you have to use the method from array. Since we have already created the np.array, now it will work like an object. Okay, so this will become like an object which has the property of the numpy. Already we have assigned it. So package object dot param any method or type method, and then which type you want to change. So you want to assign floating point 64. Okay, so let's print tab. So it will just give you. So since I have just created it, even for that you can use the tab. Float array. That's what I have created right now. So float array dot d type. So you can see I have changed the integer data type to floating point data type. Okay, by using as type method. So D type method will help you to fetch the data type of a particular array, and as type method will help you to change the data type from one type to another type. So let's do one more of this type conversion with another array value just to give you some better idea. So I have created an array and then I'm going to change that. You can see it has the decimal point too. That is, it is float actually. But I'm just going to change it to integer by using this as type method. Okay, I'm just changing it to integer array. You can see in 64. Okay. So similarly, you can do the floating to string to float conversion as well. That is also possible. So for example, let's create an array with the string and set it as a string as well by using the d type. You can set it as string. And here I'm creating an array and setting this as a string. Every value is string. 1, 2. Okay. I'm just going to use the as type to convert it into float. Come on, has. Okay, give me a minute. I will correct the code. So there are a few types. So these the values which has integer and floating part, but I'm passing it as a string, and also I'm assigning that this is a string data type, and then I'm using the as type method to convert the string into float. Okay, so that is the end of this section 1 video tutorial. Okay, so you can find this actual Jupyter Notebook video file in folio. You can find it. Okay, so you can refer it and refer this video tutorial and complete your section 1 of the exercise from section 1. Okay, this you have to save it as a section 1 Numpy Jupyter Notebook. Like that, save it, and then also take the PDF with the screen, after you run all the cells, take a screenshot, just print and not screenshot, get the PDF of this. Okay, and remember, when you have the commands, proper commands like this, when you have the commands and notes like this, you will get 5 bonus points. Okay, 5 bonus points. Don't copy and paste the code from my PDF what I have uploaded. So based on your understanding, if you update your comments in the markdown comment section, then you'll get 5 bonus points for that. Okay. See you in the section 2 video tutorial. Thank you.